Welcome back to Applied Mathematics. In this video, I want to talk about numerical graphing tools. Specifically, that's going to mean a discussion of using desmos. I've used desmos in previous videos already. You may have used it in a previous course. I like using desmos for one reason and one reason only. It's available completely free from any device that has an internet connection. Their web-based product is top-notch. They have applications for iOS and Android phones that work incredibly well. And it completely eliminates the barrier to entry that graphing calculators have proved to be for most of my life. Before I get into the content, I do want to talk a little bit about that history because graphing calculators are still, relatively speaking, a modern invention. When I was born, the first graphing calculators did not yet exist. They became popular in the couple of years after that. When I was a student, when I was a high school student, when I was an undergraduate, I was studying mathematics and physics, which meant I needed to use a lot of calculating tools, which means I needed a high-end graphing calculator, which cost me something like $300, which at the time was the same cost as all of my textbooks for the semester. Thanks to inflation, I know that very often $300 is enough for just one textbook now, but yeah. The cost of graphing calculators has come down, but technology has allowed us to not need a specialized tool for it anymore, and that's what I want to focus on in today's lesson. So let me get my head out of the way, and let's talk a little bit about desmos. The very first thing I want you to be able to do is type things in, which is very simple if you've used any computer before. You click over here at the sidebar on the left and you just start typing. If you want an exponent, there are two ways of going about it. On most keyboards, if you hold Shift and hit the number 6, you'll see the caret symbol, the up arrow that most of your calculators use as the exponent key as well. But it's sitting right there for you. Let's go ahead and make this 3x to the 4th. I then want to get out of the exponent, so I'm using the left and right arrows on my keyboard to navigate around. You can also often click here with the mouse or with the touchscreen to get other things to work out. Let's go ahead and type in, how about a minus 5x squared? And plus x plus 1. That seems like an interesting function, something relatively easy to type out. The other thing that I want to point out, especially if you're using desmos on a smartphone or a tablet that doesn't have a physical keyboard, this show keyboard button in the bottom left. I never use it because my physical keyboard makes things easier for me, but it is there. You can get your variables and numbers typed in that way without having to think about it. It has keys for exponents. It has inequality symbols, a couple of other specialty symbols that we use frequently, and it has this button over here for functions. So if you click on that, it gives you this list of all of the functions that are built into it that it understands how to graph. Some of these I'm going to be using in this course. Most of them I am not. These ones down here that are listed under calculus, exp, ln, log, I don't know why they listed those under calculus. That doesn't really work with calculus, but you know, that's fine. Yeah, in the near future, we're going to be looking at trigonometric functions And so they are all right here ready for you to use. Up next, now that we have our graph, the first thing I noticed looking at this picture is that the interesting part of the graph is relatively small, right? I've got a couple of very interesting points here, and Desmos is very good at highlighting those points for me, but they're all clustered near the center of the screen. I've got zoom in and zoom out buttons, right? So I can zoom out and verify that there's nothing around that seems interesting. I can zoom in and get just the interesting parts on the screen and cut off all the other stuff. You can also use a scroll wheel or pinch to zoom. You can shift the graph around. On a computer, if you just click and drag, you can move the graph however you want. On a smartphone or tablet, you can just touch the screen and drag it about. It works very nicely in that regard. And then if you want more control than that, I want to point out over here in the configuration menu, graph settings. I'll first point out, I have changed this around. I put this into reverse contrast mode because I think that the dark screen video works better, but it defaults to a bright screen, which is probably more useful if you are going to be printing things. The setup of the grid is not something we're going to be messing with in this course, but if you continue onward in your study of mathematics, you might find some of those tools to be useful. But then right down here, you can set the minimum and maximum value for X. You can set the minimum and maximum value for Y. You can set how far apart the grid lines are. You can change the variable names. If you want to call the horizontal axis T and the vertical axis X, you can do that all here. There is a more options, which will allow you to use a logarithmic scale. We're not going to really get into that in this course, but you might see that, especially if you go on to study more in the sciences. That's something that becomes very important. All right, so all of those tools are there. All right, let's click back on the graph itself so that Desmos knows that's what I'm trying to analyze. And I pointed out earlier that Desmos automatically noticed a couple of points of interest. Well, what points of interest exist on a graph? We've talked previously about the intercepts. The x-intercepts, in this particular case, there are 4 x-intercepts on this graph, and there is 1 y-intercept on this graph. Those are all interesting points that are probably worth knowing. The other interesting points are what we call the extrema. The maximum value, well, it's a local maximum value because while it reaches a peak here, you can see that if you go way off here, it goes higher and higher, but it keeps going up forever. That's not that interesting. We have a relative maximum right there at this decimal approximation. We have a relative minimum here, and we have a relative minimum down here. So we can find the maximum and minimum values of the function. One thing that's kind of disappointing about Desmos is as soon as I click on anything else, all of those points go away. Oftentimes, it's worth trying to keep those. So one of the things that you can do is try to write them down and then bring them back in, because again, as soon as you click somewhere else, it's gone. But I can literally type in single points by putting in parentheses and commas to get additional points to appear. And then if I don't want everything to have different colors, I can go to my edit list over here. I can click on each of these and change it so everything has the same color. I can change around the style, but I don't find that to ever really be useful. If you're dealing with a situation where you're trying to graph several different things in the same place, that might be helpful, but for my purposes, I don't find it to be that useful. All right. So with that, we have a really nice version of this graph in the computer. All right, well, I guess that's great. What can we do with that information? Well, that's where this button comes in. A square with an arrow coming out of it is called the Share Graph button. And it gives you options to print your graph, export as an image, or embed. For our purposes, either printing the graph or exporting the image tends to be the most useful. I find that it's rarely useful to change any of the settings, just keep it as it is. Download the PNG, and you can put that into a Word document or something like that, along with pictures of your written work to put everything in one place and submit solutions in D2L. All right. Let's go ahead and get a new blank graph. So that I can show off a couple of other things that tend to happen in graphs. So here I have y equals 4 over x minus 1 plus 1. You know from things we've talked about previously, if we try to set this denominator, x minus 1 equal to 0, we get that x is equal to 1. And I think it's kind of interesting to explore a little bit. What does it look like when x is equal to 1? And if I zoom out far enough, I think I have to go one more before it really gets interesting. Watch what happens when I make that x equals 1 line disappear. It's replaced exactly with the graph of the original equation. If you zoom out far enough, this vertical line has the same appearance as the graph at that point. Of course, if I zoom back in, we can see that that really has nothing to do with it. This is a structure that is known as a vertical asymptote. I guess I should head back over to my text block here. Right? An asymptote is a line a graph approaches without crossing. There can be horizontal asymptotes, there can be vertical asymptotes, there can be oblique asymptotes at other angles. But it's an interesting structure and one that I want you to be able to recognize graphically even if we don't do anything else with it in this course. The last thing that I want to look at are piecewise defined functions. So how about this one? F of x is x minus 2 if x is less than 0. F of x is x squared minus 2 if x is between 0 and 3. And f of x is 7 if x is greater than 3. If I jump over to Desmos here, I can graph each of those pieces on their own. And let's see if I come way over here so I'm not in the way. Pointing is a little bit challenging because I don't have a lot of camera space left. But over here to the left of 0, we're following along on this straight line, y equals x minus 2. Then we switch to y equals x squared minus 2, which is this curve which is going up this way. And then here, when x is equal to 3, we switch again to y equals 7, which is this horizontal line. So we're jumping between these couple of different curves. And just first glance, looking at each of these pieces gives us some insight as to what the graph is going to look like. But we can actually do a little bit better than that. I am going to click and drag on the boundary between my equations and my graphs, which is going to make the graph get really small, but it'll give you enough space to see what I'm doing here. And then the notation for entering a piecewise function is backwards of what we're accustomed to writing it out, but it's the same basic idea. When x is less than 0, we put a colon to say we want this to be, and then we type in the expression, x minus 2 in this case. Then a comma and a space, and we're on to the next one. When 0 is less than or equals, to get less than or equals, I type them in order. Less than, equals. 0 less than equal to x, less than or equal to 3, a colon, and I wanted x squared minus 2. Then, comma, space, when x is greater than 3, colon, I want 7. And another curly brace to close that. To make this stand out a little bit more, I'm going to go into my settings, and I'm going to turn that into a white graph. And then I'm going to drag this back closed. It's going to cut off a lot of what I was just typing in, but that's okay. We know what it said. And here you can see that Desmos is able to follow, piece by piece, the entire piecewise graph. I think that one might be my absolute favorite task for Desmos, because I've never met another device, another graphing tool online or a graphing calculator that's able to handle piecewise functions quite as nicely. With all of this, I'm just scratching the surface of what numerical graphing tools are capable of. If we had more time and more need, we could go into a lot more depth. We could go into even more powerful graphing tools than this. But I think this gives you a nice overall picture of what's out there and what's available. So I think I'll wrap up with that. As always, thank you for joining me, and I'll see you next time.